safe to ask any questions.
And please don't unmute yourself until the session is over, unless Gerhard is okay or fine with questions during his session. Yeah, so Gerhard, it's your turn.
Yeah, disputed.
Gerhard, you're muted.
Yeah, okay, there you go. Hear me now?
Yeah, we can hear
Okay,
you.
so yeah, let's get started. So the next, so my session is about Power BI and how to actually visualize and use it in combination with big data. I was already introduced, but here are again my contact details. Yeah, I'm working for a company called Pico, which was just like recently founded in 2019, and we focus on big data processing, analytical platforms, and AI. And we build all our solutions on the Microsoft Azure Data Platform. So that's where I get most of my inspiration and also the content for those sessions. And as I said, like today, I'm going to talk about the interaction of Power BI and the analytical platform and big data in the Microsoft Azure ecosystem. I'm also one of the organizers of the SQL Saturday Vienna, which is now, well, past doesn't exist anymore, so we renamed it to a Data Community Austria, and we will also host annual events there. So if you're interested, just go to datacommunity.at and you can follow us there. Yeah, if you have any questions, you can always reach me on Twitter or just drop me a mail. I usually try to respond within the same day if it's possible, and try to help whenever I can. Okay, so quick agenda. What's actually the reason why I came up with this session? Then we'll give you a short introduction of what big data actually is and how to work with big data. And then we will have a look at what options we actually have to connect Power BI to our big data processing engine and how we can access and visualize the data. The streaming part is still here because I didn't remove it. If anyone is interested in streaming, I can probably also show the demo about streaming, but it's actually not part of the presentation. Yeah, and in the end, I'll give you a short summary on what we've seen, obviously. So why this session? As you probably know, if you are working in, let's say, the data area over the last couple of years, the whole hype about big data, analytics, AI, etc., however you want to call it, became more and more important. And the focus for data platforms more or less moved away from traditional data warehouses to analytical platforms that are more capable when it comes to dealing with larger amounts of data and semi-structured data. But nevertheless, the results that you generate with this analytical platform at some point also need to be visualized, because you can build the best machine learning algorithm and the best data model, whatever. If you cannot visualize it and actually show it to the client what you've done, it's mostly useless, right? So at some point we need to visualize it. And as we are mainly working with Microsoft, Power BI is the obvious choice here, because it's actually the only really supported reporting tool that's coming from Microsoft in that area. So working with big data. First of all, what is big data at all? There is actually no clear definition what it is. So what I did, I just took what's on Wikipedia and pasted it here basically. So big data is a field that treats ways to analyze, systematically extract information from, or otherwise deal with data sets that are too large or complex to be dealt with traditional data processing application software. Traditional data processing application software here basically refers to a data warehouse, which is usually not built to deal with new kinds of data, like, for example, log files or binary data from IoT systems, etc. So, and these are basically the sources that we want to process in our big data platform, and in the end, visualize. So as I said, the data that we deal with is usually very, very large or very complex, and you cannot just visualize it in a very easy way, and there is always some pre-processing required to either clean the data, because not all of the data that you have available is probably useful to you, or you need to aggregate the data, because no one can look at 1 billion rows in a report. It just doesn't make a lot of sense. So there's always some pre-processing involved. There are some approaches which are basically about virtualization, schema on read, or in this case then schema on reporting. So basically you would just dump files somewhere in the data lake or on any file share, wherever. And then when you develop your report, you do all the transformations and calculations on the fly or when loading the report. But actually, I've never seen a solution where this actually worked properly, especially not in the big data area, because it's just too complex and too much data to do the calculations on the fly. So what can we actually visualize? We can visualize refined data, highly aggregated data, or highly filtered data, okay, or all three or two of them together, obviously. So how this is usually done? As I mentioned before, you will always have some pre-processing in between the data and the visualization. In a traditional big data system or analytical platform, you will at some point have some kind of storage. It's usually a data lake store. And all the processing happens in a separate engine. Most of the time, if you're working with Microsoft and Azure, it's very likely to be either Azure Databricks or Azure Synapse. But it could be any other processing engine of your choice that you like, that's able to connect to a data lake store and is able to publish the data to Power BI or offers an interface for Power BI. This could, for example, be an on-premise Cloudera cluster or a IaaS cluster hosted in Azure. So it's actually really up to you what you use as a compute engine. It's actually also up to you what storage engine you use. So you're totally flexible there. And you can also use a combination of, for example, Databricks and Synapse, which will probably also make sense in some scenarios. And that also basically shows one of the fundamental concepts of cloud processing or big data processing in the cloud, which is the separation of storage and compute. So your data resides in the storage, and whenever you want to do something with the data, you spin up your compute engine, do the processing, and store the results either back to the data lake store, or you push them to a visualization tool or to Power BI. And that's actually one of the biggest advantages of cloud-based data and analytics platforms, because it's actually up to you how much of the processing engines you actually need to use at any time. And as I said, you are actually pretty flexible on which processing engine you use, and you only pay what you use. So you can basically start your analytics platform in Azure for, let's say, 10 euros a month, if you just spin up a data lake store and Azure Databricks and only process like a gigabyte once a month, and then you still use the same components that are also used for an enterprise-ready data analytics platform. So that's totally up to you, and you're really, really flexible there. And as we have seen in the chart here, when it comes to visualizing, you actually always for the compute engine, the compute engine always have to be up and running, which means that when you want to access data from the data lake that's processed in Databricks, you actually need to spin up a Databricks cluster most of the time. So basically there's actually two ways on how you can get access to the data. And the most obvious one is using a compute engine that you already have. So basically putting Power BI on top of that compute layer, either, let's say, Databricks and Azure Synapse as the most common ones. And the other approach would be to connect Power BI directly to the storage. And the first thing that we will have a look at is what does it look like if we put Power BI directly on top of the compute layer? For most of the compute layers, they are based on Apache Spark. Just a quick introduction on what Spark is. Spark is basically a big data processing engine which runs on the cluster and is built for speed, ease of use, extensibility, and also very much for scalability. So it basically allows you to process these data volumes that come with big data, and also gives you the flexibility to actually work with semi-structured and non-structured data types, extract all the valuable information from there, and then provide the data in, let's say, a tabular format or as a SQL table most of the time. And both Azure Databricks and also Azure Synapse are mainly, or one of the main parts there is Apache Spark. Whereas Databricks is more focused on the data science part, and it's actually, from my point of view, more mature compared to Azure Synapse, but lacks a bit the SQL capabilities compared to Azure Synapse. But still also obviously offers a SQL interface which you can use to connect Power BI to. And the other part, the other processing engine is, as I said, Azure Synapse. It's basically let's say an umbrella brand across already existing data components in the Azure cloud, which is the former Azure SQL Data Warehouse, Azure Data Lake Store, Azure Data Factory, and also Power BI for reporting. And as I said before, you can also use Spark there. So there's like two dedicated, two separate ways how you can work with data there. It's either using Spark pools or SQL pools, and it's totally up to you what you use. And it, from my point of view, it very much just depends on the use case that you're dealing with. In my demos, I will mainly work with Azure Databricks, but you can imagine that everything that I show on Databricks with the SQL interface just works the very same way, also in Azure Synapse. So what are the benefits that I have when I access the data in Power BI via those processing engines? First of all, both of them offer the ability to create SQL views. So what happens very often, and is also best practice, is that you have some SQL view layer or a business layer or whatever you want to call it in your processing engine as an entry point for Power BI. So basically that everyone that connects Power BI to the compute engine knows already, okay, the data that I access in the business layer, which is usually a dedicated database, is already refined, cleansed, and contains the correct data. So that's a very important part when it comes to building an end-to-end reporting solution and having those compute engines in between, that you still somehow ensure that in the report only the most refined data and the most correct data shows up. In addition to those SQL views, where you can also do some basic calculations and joins, obviously, there is also the ability to use them for query pushdown. So if you're dealing with big data systems, most of the time you will deal with hundreds of gigabytes or terabytes of data. And as you can imagine, you can just simply process 5 terabytes of data and expect a query response time in under a second, for example. So what's very important is query pushdown, so that you can push down the filters that you define in your report by selecting a slicer or using interactive filtering, that those are actually pushed down to the compute engine, because you don't want to load the terabytes of data to Power BI and do the calculation there. But instead you want to push the queries to the compute engine, use the power that you have available there, and only return the aggregated results to Power BI. A special form of query pushdown is partition elimination or partition pushdown, however you want to call it. It's basically when you're dealing with those big amounts of data, your data is usually partitioned. Most commonly that's done by time. So for example, if you have a table that contains events, it's usually partitioned by time. And if you run a specific query for, let's say, the last month, you would use a filter on this partitioning columns, so that it doesn't need to load the events from all previous months before processing it, but only loads the events from the actual previous months. So that instead of reading the whole table, you just read a subset, and therefore it's again much faster. Another very important part for why you would use compute engines is that you can use direct query in Power BI. So Power BI, you can either use the import mode or the direct query mode. And in direct query mode, again, you send the data or the query to the underlying compute engine. It's processed there, and only the results are returned, and that's actually what you want. However, if you implement it like this, there is also a downside. So whenever you want to access the data that actually just resides in the storage, you always need to have a compute engine in between, and this costs some money and also can introduce some latency. Latency in terms that if you want to access the data and your cluster is not running, you need to spin up the cluster first. Okay, so that's also a drawback here. What a lot of people do to work around or partially work around those limitations is to add a SQL layer in between the compute engine and the reporting. So reason for this is, first of all, that a SQL database is usually much cheaper compared to a Databricks or Synapse cluster, and it's actually also more suited for reporting queries, like low latency queries or highly selective queries, because you can define indexes, etc. So that's actually a very common pattern that you will see when it comes to reporting on big data. Yeah, that's just explained it. So this intermediate SQL layer that you can use, but that's just let's say an improvement. What I will focus on for now is directly accessing the data from the compute engine. Okay, so let's do a little demo there. So whenever you want to access data from those compute engines, especially Databricks, basically you have three options. You can either use the built-in Databricks Connector, which exists since, I think, November or December last year. Or as the compute engines are mainly based on Spark, you can also use the native Spark connector. Both of them work. There are some pros and cons for both of them. I'd actually recommend to use the Databricks connector whenever possible, because it actually has some performance improvements built in, and it's also more actively developed. And besides that, it also offers the ability to pass your current user.
Ja.
Yes. Is there a question? Oh, okay.
One was off mute.
So if you're using the Databricks connector, you can also use single sign-on, and the user that you're currently connected with to Power BI or to the Power BI service is actually passed through to Databricks and then further passed through to the data lake store. So it's like a seamless experience when using Power BI with Databricks here. Databricks. So what you need to do is basically you need to define or enter a URL and an HTTP path. Those are both properties that you find as part of your Databricks cluster. I'll just briefly show you where you can find it. So in Databricks, you can go to clusters. Then you select the cluster that you want, and under advanced options, JDBC, ODBC, you will find exactly those values. Okay, so that's the server host name, and it's also the HTTP path. And once you have those entered into Power BI, you can actually connect to your data. What I have done here already, as we are actually quite short on time, is I already created a data model where I have imported some data. So let me check which ones are actually imported. This one is imported. It's in dual mode, so that can be used in import mode and direct query mode. And I basically have a fact table that's direct query only because it's supposed to be very big. And I also do have an aggregation table. Okay. For those of you who are not familiar with composite models and aggregations, Power BI offers you to create so-called aggregation tables. And whenever you're actually viewing or accessing data in a chart on that aggregated level, it can actually use the pre-calculated aggregation and does not have to aggregate over the raw data or the detailed data, which has two main advantages. First of all, it's obviously much faster if you can retrieve the value from the already aggregated table, and this table usually also fits in memory, and so you can use input mode there. And if someone decides to go down to a lower level, there's still the fallback to use the direct query one and query the data source. So, and that's what I basically built here. We can have a look here. So we do have a table that shows our sales by reseller, and we do have a column called business type as part of our reseller, which I can now use to filter my report. And as you can see, it's actually pretty snappy because the data is in memory and there is no direct query involved yet. As soon as I change the slice and introduce a new filter, making the aggregation invalid, you will see that the query is much slower. So if I select as specific ship date only, what will happen is that it actually goes back to Databricks, sends the SQL query there, retrieves the data, and then displays the data here. So in this case, we're actually using Databricks in the background to do the heavy lifting of processing our detailed data. And that's actually a very, very important part when it comes to working with big data and Power BI, because this setup actually gives you the possibility to have both snappy query performance and also the ability to drill down to the lowest detail. And how you set it up is that if you click on your original fact table that contains all the details, you can go to Manage Aggregations. Oh, sorry, no, it's the other way around. You have to go to the aggregated table, go to Manage Aggregations, and then you can basically say, okay, this aggregation table contains actually the same data as my detail table, which is the fact reseller table here, and it also shares the reseller key column and also the order quantity and the sales amount. So whenever there's a query coming in that's only filtering on the reseller dimension, it can actually be satisfied using this aggregation table, and there is no need to go back to the to Databricks to get the values. And you can also have multiple of those aggregation tables, and Power BI will automatically decide which aggregation table to use based on the filter context that you are providing or that you're selecting using your slicers and interactive filters from other charts. Yeah, I mentioned also that it is actually very important to align the report with the partitioning structure that you have, so that you do not have to query the whole table, but only the selected partition or selected partitions. So I prepared a little demo here, which takes some time in the beginning. I'm adding the performance analyzer here. So what we see here, we basically have three charts. One of them is a group by the sales territory. Another one is a group by the calendar quarter. And the third one on the right side is a group by the calendar year. And what we want to show is basically how the performance behaves when we actually filter on a partitioning column compared to when we filter on a non-partitioning column. So the fact table is actually partitioned by sales territory key. And so whenever we would select something here from the sales territory group, it would actually hit the partition filter, and needs to process much less data. So instead of previously where we had 15 seconds, it's now actually returning in 5 seconds. If we, on the other hand, try to do the same with a non-partitioning column, so just select one of the quarters, it's actually slower. It's for the data set that I have, it's not so obvious, but it's still a lot. It's already 1.5 seconds slower, which is like 25%. But this very much depends on the data set. So in my case, I only have like 10 partitions or so, and there is also some overhead involved. But if you imagine that you have, let's say, 1,000 or 5,000 partitions, if you have your data partitioned by date and by country, for example, then this obviously can make a huge difference. To see whether a partition is hit, there's unfortunately no way to see it in Power BI the only way how you can see it is in the processing engine. So for example, in Databricks. In Databricks, you see it if you go to the Spark UI of your cluster. And then you go to SQL. And then you will see a lot of queries. It's actually the same query multiple times. But those that are actually interesting for us are those that actually have job IDs associated with them. And what you see here then is basically an execution plan that says at some point it's querying my big fact table, and it does have a partition filter. I don't know if you can see it. But there is actually here, you can see that there is a partition filter, and it's actually filtering dynamically on the partitioning column based on the sales territory keys that belong to the selected sales territory group that we selected in the chart. So that's basically how you can see it. I don't know how or where you would see it in Synapse, but I assume that there is also a DMV, a dynamic management view, where you could also see this. Yeah. Any questions for accessing the data using the compute engines? Okay.
So there's a couple of questions, and I don't know if you want to take them now, Gerhard, or whether you want to save them until the end.
Yeah, let's wait till the end then.
Okay.
They're not urgent. Okay, so that's what we've seen right now is basically accessing the data that resides in the data lake store and using those dedicated big data processing engine that can do a lot of heavy lifting, but are also expensive to spin up and to use. So the alternative actually is that you can connect Power BI directly to the storage. So as you know, you can use Power Query to basically read the CSV files from a blob store or from an Azure Data Lake store and build a report there.
The Bluetooth device is ready to pair.
Okay. Yeah. So that's actually the most simple thing that you can do. It works out of the box with Power BI, obviously. And you're just using Power Query as your processing engine, which is actually quite powerful. The only thing that you need is, so as your data only resides on the data lake store or on a blob store, you just need direct access to this storage, which can either be via the storage access key, a shared access signature, or in case of the Azure Data Lake Store, it can also be a access control list that you can specify on folder or file level. However, if you connect directly to the storage, you obviously do not have the processing features available that we had with the processing engines before. And foremost, the business layer and also partition pushdown. There are obviously ways to build your own partition pushdown and partition elimination by just reading files from a particular subfolder of your data, but it's actually can get quite complicated and messy. And the biggest drawback there is that you actually cannot use direct query. So that's input mode only, as you cannot really build a data model in direct query mode that's sourced by a data lake store. Another very big drawback that you need to be aware of is the limited support for file types. So basically, in order for this whole setup to work, you need to process and store the data in a format that's also readable with Power BI. Okay, so that can either be a CSV, JSON, or XML, or since I think it is November, you can also read Parquet files. So for those of you who are not familiar with Parquet, Parquet is basically becoming a de facto standard file format for data lake stores. It's basically a columnar stored file format that's highly compressed and performs actually pretty well. Especially in the area of Databricks, you will probably also come across a file format called Delta Lake, which is basically an extension of the Parquet file and gives you some more SQL-like capabilities on top of your data lake. For example, things like time travel or update and merge statements, which is usually not supported out of the box by a data lake store. Unfortunately, there is not yet a dedicated connector for this Delta Lake tables. But actually, I wrote a custom Power Query function that you can use to read a specific Delta table, and it also allows you to do time traveling and stuff. And at least from my experience, most people that work with Databricks actually also work with the Delta file format, and that's where this custom Power Query function can come in very handy. Because if you already prepare all the data for reporting as you need it in Databricks, you can just use the access via storage approach and don't need to have a cluster up and running whenever you refresh Power BI. Yeah, so this would basically look like this. So we have Power Query as our compute and processing engine, and we load data directly from our data lake store into Power BI for our reporting. Yeah, so what does this look like? As I said, basically you can just use Power BI to connect to either a data lake store, Azure Data Lake Store Gen 1 or Gen 2, but probably will only use Gen 2. If that's your storage, you can just connect to it, connect to a specific folder where your files like CSV files, JSON or Parquet files or Delta files reside, and then just work with them as they would be local files, and just load them into Power BI in import mode. And once they are in Power BI, you get this super snappy performance that Power BI and the engine underneath provides. What you can also do is, as I said, as it was added recently, is to use the Parquet connector. So you would just point to a location in your data lake where your Parquet files reside, and then you can just read them from there directly. Okay, and what I also wanted to show you is how you can actually read a Delta table. And that's what you see here. So basically, that's the final function that I used. You basically supply a list of, or actually a folder in your data lake store, which can look like this. So you have a lot of Parquet files in there, which contain the actual data. And at some point, there is also some log files, which basically tell you which are the most current Parquet files. And what this custom function basically does, it parses all those JSON files from the Delta log, calculates the most recent version for the Delta table, and then returns only the currently active Parquet files. And then you basically get the data in a SQL format, can load it into Power BI, and it's then imported in your data model, and you can use it as you want. So if you're working with big data and delta tables, I published this function also in my Git repository, and I also recently blogged about it if you're interested there. Yeah, as I said, this only works in import mode. You cannot use it in direct query mode. What you could do theoretically, you could combine this approach with composite models and aggregations, for example, and then you would have both like access to the storage for example, those delta tables on an aggregated level, and also access the raw data or the detailed data via the compute engine. But in this case, you will probably use only the compute engine, because you usually would not want to mix those two approaches, because you either go for the one or the other. Yeah, so I already showed the composite models and the aggregations before. That's actually super important if you really need to visualize highly aggregated data, but also the detailed data in the same report and the same data model. And it actually works pretty well and keeps the data model small and allows you to build super sophisticated data models and still keep them small, so you can actually publish them to a Power BI tenant where you don't need Power BI Premium. Yeah, that's it basically with my session. So the quick summary and the key takeaways for you should be that if you have an enterprise grade reporting requirements with Power BI, you should probably go for the SQL access and the compute engines. So if you are in an enterprise scenario, you probably also don't need to worry too much about costs, and it's usually not a big deal if a cluster is up and running 24/7, for example. Especially when you combine it with composite models and aggregations, so that the cluster is not hit every time when you actually change a chart or change a filter. And if you have simpler requirements and need to have a look at your budget, having the direct access to the files can also be a very viable solution. Yeah. That's it. Gavin, you said there are a couple of questions, so
there's some really good questions. So, so Francisco asked, is Databricks or Azure Synapse used to speed up the direct query option in Power BI?
Whether they use, what do you?
So from a direct query point of view, if you connecting to one of those, I guess, endpoints, is Databricks or Synapse Analytics providing the speed?
Well, that's a good question. That cannot actually be answered that easily because you're connecting to the endpoint, but the performance is actually coming from the cluster behind it. So you can connect to an endpoint, and there is a cluster with 2 nodes behind it, but you can also connect to a similar endpoint, and there is a cluster with 100 nodes behind it. From what I can say is there is some overhead in both cases, so for Databricks and also for Azure Synapse if you're connecting to the Spark pool, because it's an MPP architecture in the background, and the data needs to be processed and consolidated there before it can be returned to Power BI, so there is some overhead. But I can't really give you an indication which one is actually faster, because it's too many parameters.
Okay. No, that's fair. So that's very much it depends answer.
Yes, as always. It always depends.
And then if you, I think it was Kushal asked as well, would this kind of model, would that eliminate analysis services?
Again, it depends, obviously.
Yeah.
So if you're using analysis services, you can load much more data into your model using the import mode. Depending on the calculations that you actually want to perform, from my point of view, analysis services is still much faster when it comes to analytical queries compared to Databricks or Synapse, assuming you have all the data loaded there.
Yep.
So, yeah.
Okay, but I mean, so analysis services might still be your endpoint potentially, but you might do some of the analytical processing on the really huge data sets on those compute engines first.
You can obviously also use analysis services in between your processing engine or your big data platform and reporting, and then use regular Power BI in live connect mode, and then query the analysis services.
Okay, good. And then Thomas asked about the data model. So is the data model in Power BI built on data from Hive tables in the Databricks Metastore, or directly the data from the data lake?
In this case, the connector only exposes tables that are managed by the Hive Metastore, and so you can only access those. So if you have data residing in your data lake, you first need to create an appropriate Hive table, a Hive external table pointing to that data before you can access it via SQL and via Power BI in the end.
Okay. And then I think it was Ashraf asked some questions about when we're using aggregations, about building relationships between a dimensions and aggregate table. But I think Tom Martins may have answered that question, I hope, in the chat. So unless Ashraf says no, we'll skip over that one. And Thomas asked, this is a two-part question. Thomas asked a question, and then Melissa asked another question on top of that as well. So Thomas asked, would it be useful hack if you process the data in the tables in the data lake by Databricks into a cleansed format and then write those tables either whether they happen to be either Parquet or Delta Lake to CSV tables for processing those derived CSV tables with Power Query into Power BI? So that's the first part of the question. And Melissa asked, adding on to that, is how often are you seeing customers create a curated set of files in the lake as an alternative to data warehouse reporting tables in a database?
Okay, so for the first questions, yes, you can definitely do that. The only thing that that you need to keep in mind is that you don't have like this, let's say, SQL layer on top of it then, and you cannot do those partition elimination and query pushdown, so it will only work for a limited set of the volume of data. But otherwise, it's a perfectly fine solution, actually.
Okay.
And the what was the other question again?
So the second part of that, or the follow-on question from Melissa was, how often are you seeing customers create a curated set of files in the lake as an alternative to a data warehouse or reporting tables in a database?
It happens actually quite often, especially in the analytics and AI area where I mainly work with, because in our customer solutions, the main output is usually not a data warehouse-like reporting structure. It's more like a side effect or something that you need to provide in order to visualize the results. But if you're talking about this modern data warehouse architecture, then you usually would dump the data at some point into a SQL-like database that's much more suited for those kind of queries.
Okay. So you might create some but as an intermediate one, you might create some refined output files effectively from the raw that may then be consumed easier from analytics purpose.
Yeah.
Yeah. Okay.
There's also another thing that you may consider, and that's Power BI data flows. So if you want to make the data in your data lake easily accessible, you can also use Power BI data flows, connect them to your Delta table or Parquet table or to your file structure in general on your data lake. And then Power BI will show you this data in a nice way or nicer interface without having to search for the data, because it just will pop up as a data flow source that you can use.
Okay. So I hope that answered Thomas and Melissa's questions. And Ashraf asked as well about what if the imported data exceeds the 1 gig size limit or the 10 gig for premium?
Yeah, well, then you need to get creative. So
yeah, that's not much. Okay.
As you know, you're limited in terms of size for your Power BI data model. If you're exceeding that size, you can either move some of the data that you have in there from input mode to direct query. You can limit the amount of data that you actually load by saying, okay, don't load the last 5 years, but only load the last 3 years. I mean, that's, I think, an obvious solution. And the other thing is you can upgrade to either from Pro to Premium. And if those 10 gigabytes are still not enough, you can go to Azure Analysis Services and host a data set there and use Power BI only for the reporting and for the visualization. But that, I think, are the options that you have there.
Okay, no, that's good. So there is a side conversation going on about incremental refresh and other aspects that need to be considered with that, but I don't think there are any other specific questions. Okay, so Jens asked a question, sorry, then. So will the query time for multiple visuals be added together for a large refresh time when direct querying Databricks? For one visual, a refresh time is acceptable, but how is it with 10 visuals?
I think it parallelizes it up to, don't nail me down on this, I think it parallelizes it down up to 10 concurrent queries.
Okay. That sounds good. And I think that's all of the questions, unless anybody else wants to, unless I've missed something. There is that side conversation going on, but I think that's
Thomas already answered most of them.
Yeah, it looks like Thomas is already there. So so Jochen asked a question as well, as when connecting from PBI to a data lake v2, you only have the option of authenticate via storage key or managed identity, not via SAS token. Can you share best practices here, or what works best?
Okay, so when connecting to the data lake directly, in a regular scenario, you will probably not have access to the storage key, or I hope that you don't have access to the storage key. Or let's say a report developer should usually not have access to the storage key. So you would only have the option to use the managed identity.
Okay. So Jochen, I hope that helped.
Sure, that's the confirmation on that. I hope that maybe there's a trick also to use tokens, because as you said, storage keys are no options, and I found it very tricky with the managed identity regarding the outback roles you need to be a member of, and so.
So yeah, the actually data lake store chain 2 is really picky there, and it's actually really hard to set it up, even though it sounds super simple. You can either use like this role-based access control, where you need to either be like storage blob contributor, storage blob reader role, which is basically like a global role on the data lake store, or you need to define access control lists on the files and folders, and that's also very tricky because there are some caveats that you need to be aware of.
Yes, agreed.
Okay, I think that's probably it. Unless there's any takers for one more question, we're a little bit over time. I think that's it. Just rewinding.